I am Anil Kumar. Welcome to my series on trigonometric functions. We'll discuss transformation of functions in this particular video. Take it as a quick review on the chapter transformation of trigonometric functions. We'll begin with cosine function as shown. We'll try to understand how do we find principal axis, amplitude, range, phase shift, and period, and then sketch this particular graph. And then we'll take a question related to tangent function, which will also plot the graph for. And then we'll take a question based on sine function, try to read the values from the table, and a general question on time period. With this, we'll understand the three primary trigonometric functions and the concepts behind transformation of trigonometric functions. So I hope this video is going to help you to review the learnings on transformation of trigonometric functions. Let's begin with the very first one, which is f of x equals to 3 cos of 2x minus 60 degrees minus 1. We need to find the principal axis, the amplitude, range, phase shift, and period of f of x, and we need to sketch the particular graph. So these are the two things which we need to do. To describe the transformation, it is always a good idea to factor the argument. Coefficient of x should always be 1. So let's rewrite this after factoring. So we have cos of, we'll take 2 common, x minus 30 degrees minus 1. That gives us a clear idea about the phase shift or the horizontal translation of 30 degrees to the right. Correct? Now from here, we can write down all the answers. So let's begin with the very first one, which is axis. So the principal axis is the line midway between which is normally where the x-intercepts will lie. Now that has moved 1 unit down. So principal axis is 1 unit down, and that is the value of y. So let me write down this axis as y equals to minus 1. Amplitude is the maximum value, which you see right there is 3. Range. Range are the possible values which the function can have. Now in this particular case, we'll just sketch a rough graph here to understand. So since it moves a bit on the right side, so what I'll do is I'll just sketch a cosine function which starts with a maximum, kind of like this. We're making a rough sketch. We'll actually sketch the function on a fresh page. So first of all, we found the axis, and this axis is at minus 1. Now from this axis, you have to go 3 up. So you have to plus 3 to go 3 up, and you have to go down. So you have to do minus 3 to go down. So that point will now be minus 4. And the maximum will be minus 1 plus 3, which is going to be plus 2. And therefore, we can now write down the range. So range will be from minus 4. So that is the value of f of x to 2. So basically range you get by adding and subtracting the amplitude from the axis. Phase shift. Phase shift is how much did the graph move left or right. So in this particular case, the phase shift is 30 degrees. You only get this correct value if you factor this argument x, correct? So that is very important to understand. So that is why if you don't do this, you may get a wrong answer at this stage. So let's write down the phase shift, or the horizontal translation to the right is 30 degrees. So when I am writing 30 degrees, it means right. and the period of the function. The value this 2 decides the period. It means there are two waves in 360 degrees, right? So the period P is basically equal to 360 degrees divided by the value of K. Now in this case, it is 360 degrees divided by 2, and that gives you a value of 180 degrees. In general, I will be writing the trigonometric functions as a f of x as equal to amplitude A times, it could be, we could have a sign negative or positive depending on whether the graph is reflected or not. So any trigonometric function, let me write cosine here, cos of k x minus phase shift p plus, let's say, q, translation up and down, the axis. So that is how you could actually describe this particular graph's transformation. Now let's move on and see how to sketch the graph of cosine function. Now let us try to sketch the graph of the function f of x equals to 3 cos 2x minus 60. We have already done the first part, which is how do we find the principal axis, amplitude, range, phase shift, and the period. And now let us look into the second part, and that is to sketch two cycles of the graph of f of x. The function given to us is f of x equals to 3 cos, you need to factor 2. So let's write it with factored form, x minus 30 degrees minus 1. Now when we want to sketch the graph, I prefer to do it in two steps. So I'll explain you the method, which is basically a two-step method. In the two steps involved, we will first sketch one cycle of the function, which will be, let's say, y equals to 3 cos 2x minus 1. And then we'll sketch the second cycle, which will incorporate the shift of 30 degrees to the right. And then we will from here transform it and then sketch 3 cos 2 x minus 30 minus 1, two cycles, correct? So that is the steps involved. I'd like you to watch some of my videos on two-step method. Here I'll describe the process in short. So let us say we want to sketch the graph here. We'll now sketch the first part, which does not include the translation left or right. 3 cos 2x minus 1. So we begin with the axis itself. So the first thing which you have to take care of is the axis, which is minus 1. Let us say this is minus 1 for us. So we'll sketch this axis. This is y equals to minus 1. And now we'll consider the amplitude of 3. That means from the axis, you go 3 up and 3 down. So let's say this is 1, this is 2, and this is 3 up. So that is your maximum limit. And then 3 down means 1, 2, and let's say this is 3 down. Let me just sketch this. Okay. So we have this axis with us. Let me make it shorter. Okay. Now we look into the period of the function, which is defined by 2. In this particular case, the time period for one cycle is 360 divided by 2, which is 180, which we just calculated. So looking into our space, we'll kind of divide this as this to be one cycle of 180 degrees. So let us say this is at 180 degrees on our graph paper, right? Okay. So we have our framework. Within this framework, we are going to use 5 key points of cosine function in sketches. Cosine function, as you know, starts with the maximum, right? So, and it goes to x's, comes back to minimum, back to x's and maximum. So those points happen to be at 4 quarters. So we are going to divide this into 4 quarters. So let me divide this into 4 quarters. So see how I'm dividing it into 4 quarters. So what I'm trying to say here is that on your graph paper, this will be like 90 degrees, this is 45 degrees, this is 135 degrees. Perfect. And the points for cosine function can now be plotted with the process of identifying the maximum, right? And then the axis. So in our case, the axis now has shifted, and then the minimum, axis, and the maximum. Do you see one particular cycle there? So that becomes one cycle of the cosine function. You need to connect these points with a solid graph. Do you see the first part? So what we have done here is basically sketch the transformed function without including the phase shift. Correct? And now, in the second process, we'll actually include the phase shift of 30 degrees. 30 degrees, let us say, is kind of here. So divide, we know that much is 30 degrees. We need to shift every point 30 degrees to the right. Perfect. So once you do that, you have your graph. And now let us sketch the graph itself. Now the graph can be connecting these points. Since we have these points right there, we can sketch one cycle of the graph. So that is one cycle of our function. Now once you have this particular cycle of your graph, you could actually repeat it. That's the whole process. Correct? So now you could repeat the graph which you have and make the second cycle. So let us say that was 180 degrees. These were divided into quarters. Correct? And then we move the points 30 degrees to the right. So instead of having the points on, so the next point here will be, so you have to just add these points and get your graph. This graph is going to end right there, 30 degrees to the right of 360 degrees. Correct? So you can mark this point here as 360 degrees plus 30 degrees, which is going to be 390 degrees. Correct? So that is how we are going to sketch the graph of the function. At present, I'm just marking the points here, and we are going to connect them. So the second cycle will be connecting these points. Is that clear to you? So that is how we get 2 steps to sketch the graph of the function. Perfect. You could also find the points, the key points, and then sketch it, which is the normal way. However, this process of 2 steps is very convenient, where you can sketch the graph without any calculations. Now let's look into the second part, which is the second question, which is based on tangent function. The question here is, sketch two cycles of the graph f of x equals to tan of x minus 45 degrees, where x is greater than 0 degrees. Label 5 key points in the cycle of the graph. So now we'll sketch the tangent function. So basically, you know that tangent function is defined one cycle between minus 90, where you have a vertical asymptote, and plus 90. It goes through 0, and these are the two asymptotes at plus and minus 90. At 45 degrees, we have a value which is 1. So I'm marking these key points here. We can actually make a table and also write these points. So we'll do that also. So let me say that this is the basic tangent graph. Correct? So that is the tangent graph for us. Normally, you'll sketch it like this. On a table, you can always write your values. So two critical values which we'll always consider will be the vertical asymptote. So we have a vertical asymptote at x equals to minus 90 degrees, right? The other one is at plus 90 degrees. So those are the two vertical asymptotes which we're talking about. For the parent function tangent x, I mean. Correct? The key points, which are these three key points, they are at minus 45 degrees. We have value minus 1. At 0, it goes through origin. And then we have 45 degrees, 1. So these are the key points. For sketching the cosine function also, you could go through this process. But I'm just showing you two different ways of doing it. So these are our x and y default values for tangent x. And now let us write down the values for the function f of x, which is translated 45 degrees to the right. So the y values now will not change, but the x values will change. To the x values, we are going to add 45 degrees, right? So as far as the x values are concerned, the vertical asymptote will now be at x equals to minus 45 degrees. And here it will be at x equals to, you have to add 45 degrees, right? So basically, the transformation here is that it is x plus 45 degrees and the y values remain same. So when you add 45, you get 135 degrees for the vertical asymptote. The other points in between, the x value for minus 1 is now going to be at 0. So to minus 45, when I add 45, I get 0. The y value will be minus 1 itself. So those will be our transformed points. Right? So with these transformed points, let me now sketch the graph of tan minus 45x. So we are translating this particular graph by 45 minutes to the right. So 45 minutes means that now the graph will have the vertical asymptote at minus 45 and 135. The cycle still remains as 180, correct? So in our graph, 1, 2, 3, 4 divisions are for 90 degrees. So for 45 degrees, we will go for 4 divisions. That is, this is the next 45 degrees. And then 1, 2, 3, 4. That will be the next vertical asymptote. This is for the second cycle. So we'll go for 8 divisions, 1, 2, 3, 4, 5, 6, 7, 8, somewhere there. Okay. So that is how we will have kind of divisions. But anyway, we have enough space for our first two cycles, which are going to be in this portion and that. Now, translating the graph 1 unit, which is 45 degrees to the right, we get these points translated. So let's look into the translation now. See, this point will translate to that. The vertical asymptote will translate to this point. So that is how it is going to get translated by 45 degrees. So we get a new graph, which is translated graph with key points translated as I'm going to show you here. The vertical asymptotes I've already drawn, so I could now sketch my graph, which is that clear to you? Similarly, I can sketch the next part of the graph. The key points now can be placed 180 apart, and you can sketch the graph. Correct? So that is how we are going to do the needful. Connecting these points, which you see here, we get the tangent function. So what we did was that first we have drawn the parent function. So we have this as our parent function. And then we translated 45 degrees to the right to get the transformed function, which is tan of x minus 45 degrees. Is that clear to you? Correct? So the key points for the parent functions are shown here. And then we transform that, and then we got the final points. So I think the steps are absolutely clear. So that kind of is very easy to sketch the graph and really helps. You could label your graph with your key points. The points are already given to you. These are the key points which you're going to label one cycle with. Always mention at least 5 points. So the vertical asymptotes at 45, the vertical asymptotes at minus 45 and 135 degrees, and the 3 points 0, -1, 45, 0, and 90 degrees 1 will be the base for our graph. Correct? So these are the key points along with the vertical asymptotes. So I hope that is absolutely clear. Now let's take the next question, which is based on sine. It's a very good question. It says, the figure shows part of the graph of f of x equals to sine x plus p, where p is greater than 0. So there is a phase shift. The graph has moved left by p units, as is very clear from here, right? It crosses the x-axis at a. It crosses x-axis, which are these 2 points, at a 150 degrees 0 and at b, which is b 0. It crosses y-axis at c, which is 0 c. The maximum value is m. Find the value of these p, b, c and the coordinates of m. That is the question for you. So you can now pause the video, answer the question, and look into my suggestions. So the function which we are working with now is f of x equals to sine of x plus p. The only transformation is p units left. Now p is what? How can we figure out? The point here, which is the x-intercept, gives you an idea about the units moved left. Normally, a sine graph will be kind of, let me just sketch here. So it'll be easy for us. Okay. So normally, the x-intercept in the center will be at 180 degrees. Now here it is 150 degrees. So basically, it has moved left by 30 degrees, correct? So when you take away 150 from 80 degrees, you get 30 degrees. So the value of P is 30 degrees. So we found the value of P. Now that also means that all other points have also moved 30 degrees left. So this point was 360 degrees and the other one was at 0. So that gives you these points which are minus 30 degrees and this becomes 300 degrees, 30 less. The maximum, which would normally occur at 90 degrees, the value will be 1, will now be 30 degrees less. So the value of m should be 60 degrees and maximum remains, the y value remains at 1. The x-intercept was 0. But at 30 degrees, what is the value of sine function? That point now moves to the x-axis, right? So this point, when you substitute x as 30, x as 0 and p as 30, we get sine of 30. So we can find the value, y value of y-intercept as sine of 30 degrees. Sine of 30 degrees can easily be calculated using special triangle. So this is a special triangle where the sides will be 1 to square root 3. That is the angle 30 degrees and this value is half. So we know that the point C here is 0 half. Correct? So easily we can find all the parameters as shown on this particular graph. I hope you understood the method by which I found it. The idea to share with you is how quickly we can actually get to all the values. So now we can write down the answers. We know P is 30 degrees and then the value of B, which is the second x-intercept, is basically 300 degrees. The value of C, which is the y-intercept, is equal to half, and the value of the coordinate points M are 60 degrees 1. Is that clear to you? So that is how we are going to answer this particular question. Now let's move on and take the last question, which is, consider the function f of x equals to sine kx. The graph of f of x crosses x-axis at 36 degrees. What could be the minimum value of k? So let's try to sketch the function. A sine function basically will be like this. But when I say it is y equals to sine kx, in that case the time period will be that particular cycle which we are talking about is going to be 360 degrees divided by k. In our case, we need to find what k is. However, we are given one particular value, and that is, we are given that the graph of f of x crosses x-axis at 36 degrees. So normally, this will be 180, but now we are saying this particular point here is 36 degrees. So that really means that will be 72 degrees, the time period for this particular wave. So that should give you the value of k, which we need to find. So I hope that makes sense, correct? So the value of k can be found. We know 72 degrees is the time period. So the value of k is, let's write down, k will be equals to 360 degrees divided by 72, and that gives you the value of 5. So in our case, option C is the right option. So I hope that makes sense. The graph of f(x) crosses x-axis at it. We could take 36 either way, but we'll go for the minimum value, correct? Since the question also includes the term minimum value of k. So the first point where it crosses is at 36 degrees. You could also work this out by taking the ratio from 180 degrees. So normally this would have been 180 degrees. So you could divide 180 by 36 to get your answer as 5. That could be an alternate method. So follow the method which you feel more comfortable with. So with that, we end this particular video where we have learned how to sketch the graph of cosine function in 2 steps. You could use table of values as we did for the tangent function, no harm. So if you have a graph, very easily you can plot the final points and connect them. We have seen how to read or interpret the graph and find the values of a transform function, and that was a multiple choice question on the period of the function. With that, we conclude. I hope that helps you to understand and kind of review the concepts learned on transformation of trigonometric functions. Thanks for your time. Feel free to write your suggestions. If you like and subscribe to my videos, that'll be great. Thank you and all the best.